combo lords out there who happen to be joining me in the present or future. And checking the comments momentarily, I can note to whoever mentioned 2 with any nth hyperoperation, as they're putting it there, to 2 equals 4. And that is correct and quite interesting. Now, 2 in this case is not necessarily a level of growth when combined with itself, as we'll see. Normally, you may think of 1 under multiplication as an element that stays stable, and 2 as an element that grows, because if you tack on a bunch of 2's, you get something big. Tack on a bunch of 1's with multiplication, you don't get anywhere. However, under this new rule, if we ask ourselves, if I take just a pair of a number, but any hyperoperation, 2 isn't the one that grows. 3 is. And this is, in fact, something that will be mentioned in my Threvens and Throds book that I'm writing as well, because the fact that 2 gets so much credit and multiples of 3 don't could maybe be improved upon if we point out a few weird cases where 2 kind of has traits similar to 1 almost, and 3 breaks outside the box. Now, what is a hyperoperation? Well, it was the topic of one of my most popular my most popular main channel video called The Rare Levels Beyond Exponents. And I'll do a little re-explanation of what took place in that episode first, for anyone who needs to get a catch-up on what a hyperoperation means. Now, the cool things about hyperoperations is that although they quickly seem almost nonsensical in terms of trying to understand what they're trying to convey or when you might use them, they really are just further levels on a rung that you do definitely know the first few levels on. There's nobody who watches my videos who doesn't know at least a few hyperoperations, and that's because addition and multiplication are included. So let's look at the first ones we know, and I'm going to do it briefly on this whiteboard, but we're also going to pull open a graph. And here on the whiteboard, we'll note if I have a plus a plus a bunch of times, we consider this similar to a times some amount of thing. It's even in the name, some amount of times. And the pi in the power tower of 4, someone mentions in the comments, was in the episode I mentioned. And it's basically the thought about how pi tetrated 4 we know shockingly little about. And here we can call this level 1 of some sort of chain where when we get to a times b, and I'll do the dot for times there. Actually, what I like to do, this is sort of my combo class style, is a super miniature X, almost as if it's a dot, but with a few traits of that times that you've seen from a lot of uses of multiplication. So then if we get, okay, I got a times a times a times a, well, we could call multiplication level 2 there, sort of, having gotten an a times b. And we could say 1, in fact, would be more just making addition, a little bit up there. And here we could say level 3 is defining this series of multiplying a's as here a to the power of some b. And now the logical next step, if you thought there's going to be a continuation to this, is, well, here I took the last operation a certain amount of times. So now I'm going to take this letter to the operation of exponentiation in a string. And at this point it matters which way we read the string, because a times b is always b times a, but a to the power of b is not b to the power of a always. And so in a tetration stack like this, which would be called a tetrated 4, basically like we'd call that a times 4, a to the power, or that would be a times 4, That would be a to the power of 4. And that would be a tetrated 4. And so there's a few ways to write that. We can write it with this double arrow upward notation. We can write it sort of like people were putting the level in brackets. And that's because we're on the 4th level is tetration. When we describe tetration one of these ways, we're on level 4. And we know levels 1 through 3, addition, multiplication, exponentiation, but level 4 is the first one that for some reason they don't teach to everyone in school. But it's very interesting. Now, we could go further and add higher numbers in there. But the interesting thing about these hyperoperations, like I hinted at hexation in the title, and I ended up going with a very alliterative title where you use the same first letter a bunch. I like those. But I almost called this cursed hexation, because part of what we're going to go toward in this episode is how you can make with relatively small numbers in all of these something to some operation something. With small numbers for all 3 of those, you can make something absurdly big. And by absurdly big, I mean beyond the level of what we can imagine. It's hard to even imagine a representation for it that's not using these upward arrow-like things. Now, let's also pause to think, what does it even mean to be a representation of a number? Because when we start to say, well, it's hard for the human mind to conceive Googleplex, well, that is hard, but it's also probably impossible for the human mind to even conceive 50 to the power of 50 of a thing. Like, 50 to the power of 50 of a thing is so unbelievably large, that would be somewhere around the scale of imagining all of the atoms in the observable universe and actually imagining the scale of all of them at the same time. Atoms. So, I feel like even before Googleplex, you get to numbers that we can only understand in terms of a representation. We can try and break this down in our head and say, okay, I have something that was 50 and then 50 times that and then 50 times that. But at some point we have these boxes of 50 times, no longer feeling like we're imagining 50 of a thing. We're starting to just imagine symbols or these metaphorical boxes that the symbol is capturing. And so when we look at even something like this, we are a layer deep with requiring symbols to try and use it or to think about it. And the crazy thing is about when we get up to stuff like hexation, we get layers deeper on that. You can only understand them with symbols that are boxes of an insane amount of another symbol that are boxes of an insane amount of another symbol. And so it's in a way similar to how we can't understand this, but levels deeper. And it makes some of these numbers feel sort of cursed when you look at, for example, the number that I almost made the theme about today, but maybe I'll dedicate its own episode or something to in the future, is one number we're going to hint toward and probably not reach with our understanding, because we'll probably already hit the limits of how crazy these are a little earlier, is I was thinking about the number 666 the other day because it showed up on my triangular numbers list, and I made a short about a bunch of fun facts about that and may make a whole episode sometime. And it's interesting to think about because it does have more seemingly mathematical facts than the average number. More interesting traits about it. Now, there are 2 reasons for that. One reason, well, I mean many reasons, but 2 of the main reasons are, one is that it has a few distinct properties. It's a rep digit, meaning it's a multiple of a hyper-11, and it's also a triangular number. And those things give numbers interesting traits. But it also just has been studied way more throughout history because people are like, 666, the mark of the beast. And so it's gotten studied more, and people have found more interesting things about it as well. So some people like to think of that as a cursed number, but it's a rather pleasant number. It's a triangular number. I love those. It's also a rep digit. That's pretty nice. So I say the actual cursed number is 666, but that middle 6 is in these brackets conveying what level of hyperation we're on. This number could be called 6 Hexated 6. Hexation is our 6th level. We've only talked about Titration, the 4th level. We have to pass by Pentation and then get to Hexation to think about this. Now, this is one of those numbers that to try and understand, you have to have boxes of symbols in your brain to even try and get to the state where you're imagining a tower of exponents or tetrations even. So I say in combo class, this is our truly cursed number because it shows how with a minimal amount of symbols and the right rules, we can make something beyond our capability capability of understanding really quickly. And that's kind of cool. Kind of scary that it means our mind can't do it, but of course there's going to be numbers along the infinity past the point a mind would be able to understand. And it's kind of cool that we can make a mathematical system that logically just uses this little phrase to already be so far beyond what I could imagine as a number in real life. So let's try and get up there. And first, we're going to take a little detour. What we're going to do is, before we go past Titration, let's look at some Titration things on a graph. Now, some of these things were already hinted about in my main channel episode that I'm not going to go into all of here. I'm going to go into some new thoughts here, or ways of conveying it. So, if for some reason you haven't seen the most popular episode on my main channel from like half a year ago about the rare levels beyond exponents, watch that after the stream too, because what that'll show that I'm not going into today is a lot of ways that E pops up in Titration, the number E, and additionally this cool fractal that is generated by Titration. So those I already went into. Today what I want to just look into is, what are we really trying to get at when we get a really big Titration? Well, one way of trying to imagine it is points on a graph. So we're going to use that visualization to look at some smaller ones. For example, if I think about tetrating, and that is the two upward arrows in this, but there is another way of writing it. We could write it like an exponent before the number instead of after. And I'm actually going to write it like this for a moment because it's going to help us out maybe in trying to understand pentation. And so what we have here is, if I try and tetrate stuff, and I go 1 tetrated to 1, that's 1. We're not going to talk about 0 today. That's a whole nother story. We're trying to tetrate these things to 0. We're talking about 1 and upward today. Another day we'll get into tetrating tiny stuff. So 2 tetrated 2 is 4. And here's where all the comments are noting 2 to anything is 4. And it's true. 2 plus 2 is 4. 2 times 2 is 4. 2 to the power of 2 is 4. And it does logically continue, because when I say 2 tetrated 2, that means there's a size of 2 in the tower, counting the base. So, for example, if I tetrate something to 1, that's just the number. If I tetrate something to 2, that's it to its own power. Tetrated to 3, I may have gotten sidetracked when I was saying this, but we have to read this from the top downward, which means if I was going 2 to the 2 to the 2 to the 2, which is 2 tetrated 4, then I have to do this part before I do that part. And it actually will make a difference in some cases, in most cases. And here if I have these, I'm like 1, 4, 3 tetrated 3 all of a sudden is really big. Let's look at, it's not one of the ones we can't imagine. This is within imagining. It's going to be hard for us to imagine this amount of thing. Arguable whether a human can actually imagine this amount of a thing or not, but this number would be on the fence of that. So let me shrink myself for a moment, and we're going to pull up some stuff. First, we're going to shrink the delayed version of me with the chat, shrink this little thing of me. I need a second monitor for all that stuff, and maybe I'll get that before grade -2. And here we're going to do on Wolfram Alpha before Desmos, we are going to just look at what 3 tetrated 3 is. And just to make sure we get this right, I'll put 3 to the power of putting these in parentheses, because that'll tetrate it. And, yep. So there we got millions, billions, 7.6 trillion about. So that might be beyond the amount that a human can actually comprehend. It says it's a third of the amount of red blood cells in the human body, and it's 25 times the number of stars in the galaxy. Yeah, that sounds pretty hard to comprehend actually as an amount of a thing, like trying to picture that many dots and actually imagine them all. That's sort of on the fence. So we can imagine that 4 tetrated 4 is just absurd. Like, trying to just break down 4... so this one was big, we're going to say. But trying to break down 4 tetrated 4 is just crazy. So we got 4 to the power of 4 to the power of 4 to the power of 4. So what that gives us is we have 4 to the power of 4 to the power of... what is that 256? Let's see. Yeah. So 4 to the power of 4 to the power of 256. So what's 4 to the power of 256 next? That's this. So 4 to the power of this is what 4 tetrated 4 is. 4 to the power of this. This many 4s multiplied together. So, when we try and get there, let's see if they, for some reason, tell me any data about that. 4 to the power... no, the result, they don't do that. Okay, 4 to the power of... let's see if there's a way we can make them do it. I don't think they're going to do it. Okay, so it's this many... it's more than Googleplex digits. It's basically like... if you took Google to Googleplex, it's past if you took Googleplex to another level beyond. 4 tetrated 4. So, it gets pretty hard pretty quick to break these down. And to look at it graphically really quick, if we look at x to the power of x, this is telling me about stuff tetrated to 2. Now, if I go x to the x to the x, we're tetrated 3. X to the x to the x to the x. Ignore this little zone down here. We're going from 1 up. We will discuss, like I said, tetrations of tiny things at a different point. Now, if we're here, we got... okay, on my red line, I can see something like 4 to the power of 4. That will touch the red line at the number 64. Up here. And wait, something went... no, it'll touch the red line. 4 to the 4 was 256. It'll touch the red line up at 256. Now, what about 4 to the 4 to the 4? When is that going to touch... when is 4 here as an input going to touch the blue line? Well, what about the green line? When 4 touches the green line, the y-coordinate is 4 tetrated 4. And we can see that the green line is going to take a really long time even to get there. And then to pass that, it's going to take a really long time to pass any point on here. And it's going to take that number that was so many things, it was more than Googleplex digits of the y-coordinate when that line will touch 4. So these things go up pretty quick. Now that's just tetration. It would be hard to make them graph pentation. I don't know how I would do that, because I don't think they're built to graph tetration. I had to trick it by writing the tetration as the stack of exponents. Now, what about pentation? What if we tried to pentate something small, to just do a little, tiny little pentation? Well, if I pentate something to 2, n pentated to 2 means I have a stack of tetration with a height, including the base, of 2. So that means I would have n tetrated to n. So this shows us that 4 pentated to 2 is that absurd number we talked about. What if we tried to do, let's say, 3 pentated to 2 and break that down to start? 3 pentated to 2 is 3 tetrated to 3, and that gives us that number that was around 7 trillion. What if I tried to do 3 pentated 3? Well, that means I have 3 pentated 3 pentated 3. Like tetration, these stacks always read downward. So that means first here I calculate, this is 3 pentated 3. We said 3, oh no, this is 3 pentated 2. 3 tetrated 3. And we said that that was that number that was in the 7 trillions. What that means is that I have that number in the 7 trillions that 3 is tetrated to. That means that 3 has the exponent stack of more than 7 trillion of those. So that gets big pretty quick. Now, what if I try to do 4 pentated 4, that would just start to get insane. So I'm going to take a look at the comments for a minute, and then I'm actually going to just grow myself again so I can look at the comments on here. And then we will talk about the spooky 6 Hexated 6. So, thank you all for joining me. We're doing a momentary chat break. Afterward, there will be timestamps and chapters and stuff of when we talked about what. And so, to everyone joining me here, you may have noticed you probably saw the bonus video if you're watching this stream, but maybe a bunch of you didn't have time to or didn't see it pop up. This channel does have a different name. Yep, same thing. This is what was called Combo Class Bonus. That channel is this. We're going to have the same awesome content. There might be some extra stuff thrown in. I might drop some music videos on the channel this year or other things, but there will be just as much or more, because I'll be able to schedule it better, of super cool math stuff and science stuff as usual. And in fact, as I've hinted at, I'm in the process of quitting my private students, my old music students, to have more time for grade -2 than I did for... I spent like all my free time practically on grade -1, but now I'll be able to treat it a little more like a job and be able to have scheduled stream days starting in March, be able to have more days lined up with camera people to get all the types of content each week, like the shorts, the live streams, and the full episodes. And also just be able to do a lot of cool new experiments, such as one related to some new keys I have somewhere right here, which in a previous stream some of you may know what these are for, but I'll be revealing those with more detail tomorrow in a bonus video. And let me take a peek at the comments. I said I was going to, but I just went on a little tangent first. Thank you all for joining me. Super awesome. Someone is mentioning something called the Ackermann function, which is another one of these fast-growing hierarchies. And someone's wondering about things like fractional ones and other cool stuff like that, negative ones. We can try and expand this in the future to other really cool things, and you in fact do get a fractal that we'll take a peek at later. I didn't make one. Maybe in the future I'll have someone in the team to do that. But we can look on Wikipedia. It has some pictures of a few of the fractal shapes you can get when you do see on the complex plane of complex numbers, sort of similar to the Mandelbrot set, having a color coding based on which points diverge to infinity when you keep tetrating them to larger and larger numbers, and which points don't diverge toward infinity, and which rate they diverge toward infinity if they do. So similar to the Mandelbrot set, you can do tetration fractals. I'm not sure what has been looked into as far as the possibility for pentation fractals, so that's something I will have to investigate later. Now, someone's also mentioning superfactorials grow very fast, the product of the first n factorials. And you could also do a really, even probably bigger one would be to, if you want factorial something in parentheses and then factorial that, which you have to put them separate, otherwise it's with a parenthesis between, otherwise it's interpreted as this thing called the double factorial. And so if you do that, or you want to keep throw an extra one on for fun, that will grow really fast. But it won't grow as fast as the hyperoperations. Someone's wondering if grade -1 will have an exam. Now that's a good question, because normally I don't like tests very much. I was always pretty good at tests. It helped me get A's and sometimes B's in school, even though I was often late to class or doing my own thing. And so I never liked tests, although I was pretty good at them. They don't seem to be the true test of someone's understanding. I would say ability to solve problems that you encounter, ability to experiment on your own and test out other things and find connections. I find those more valuable than somebody's ability on a test. However, when you have to take a test, it does have some benefit of forcing you to try and re-engage with all the material and really check, did I get all that? And if your test isn't a huge grade or important thing, which it shouldn't be, a test that doesn't change your life for the worse if you do bad on it, could be just a gauge for what parts of what you thought you understood you kind of didn't. Maybe you took the test and there's some stuff that when it came up, you realized you didn't know what tools to use, or you tried the tools and they were wrong. So it can be a gauge for what you did or didn't understand out of it and what you might want to go back to. So while I originally was, my feeling like a month ago would be, no, there's not going to be a test. I hate tests. Tests are not the true value of someone's intelligence. However, just because it does force people to re-engage with topics and think in different ways, I may make an optional test that I would post on the subreddit in Discord or something, or maybe go through in a bonus video. So I may make an optional test with something that occurred to me a few weeks ago, just with a few further questions that would require you to there would only be like 10 questions or something, but each of them would require you to remember something that we've learned, that it will be stuff that's definitely been in a main channel episode, and a lot of it may have been talked about in various places on this channel as well, but I'll make sure it's stuff that was all at least covered on the main channel, and something you learn there, but mixed with having to use the tool to do something else. For example, an obvious one would be giving a number and saying, tell me how to write this in these different bases. Now, you not only have to remember how those bases work, but you have to do a little work yourself. So that's something I might try and do. Maybe I will try and have a test for the grade. I'm not promising that because there are other promises I've made that I will hold, and I'm not sure how busy I'm going to be over this month, making sure everything comes to fruition. But it's something that's on my mind that I'll, more likely than not, probably make a optional test. And to anyone who wants to, quote, study for that, you could study the main channel, because I know that the stuff I put on the test will have at least been covered on there. So, one obvious question, if anyone wants to prep now, is somewhere on there it'll ask you to write a few numbers in some of the weird bases we've talked about. I also heard the noise I love, which is a noise of a very soft thing landing on my windowsill, and that soft thing is my cat, Dandelion. Hi, Dandy. Who's a good boy? You see our Dandelion here? He's such a sweetheart. So, I'm going to soon switch back to the other not looking at the comments style. But in any case, and whoa, this is weird. It's really delayed. I don't know if it's always this delayed, but to have it on the good quality, I guess it takes a while. I'm using a new or different webcam that I only used a while ago. And on this different webcam, it's higher quality, but maybe it's making it take longer because I'm seeing myself right here and I'm like a minute behind or something. Maybe more. So, warning that if anything really crazy happens, like a lightning strike, you guys are going to get it a minute late. Also warning that that means that if you comment something in response to something I do, I'm not going to see it for a minute or so. But, you know, I'm going to look into the stream tech over this next month or two, because in March we're going to have a few steady streaming days. There's going to be one day a week I'm always on around this time, and one day a week I'm always on around like 10 hours before this when it's my morning. And then there's also going to be a bunch of random other ones that are going to just be like how I've been doing streams. Super random ones. And yes, Dandelion is such a sweetheart. He is the best. So, someone's wondering, when am I going to make... Oh, and maybe I'm not as delayed as I thought. Okay, never mind. My stream was looking at it weird. We're like maybe 30 seconds delayed or something. When am I going to make a video about my cat? Well, a lot of the videos on the main channel, the ones where the cats they've snuck in random things, but the main times they might show up are the ones called snack breaks, where I sort of take a breather to eat some foods in my garden and talk about some botany type stuff. And maybe I'll do instead of like a snack break, a petting break, where we pet Dandelion and talk about cool traits about cats. There's actually something pretty neat I want to show you guys, which is, so I've given them catnip before and like cats, so they like catnip. But the other day, my brother house sits for someone who has cats who had these extra sticks they had bought that are like sticks for a cat to play with. And they had extras that they gave to my brother to bring back to these cats. And at first I'm like, oh my god, the cat companies really got away with selling sticks to rich cat owners. Rich not meaning my family, we just inherited them. But really, it turns out they're a special type of stick. And I want to look it up right here. Hey, Dan, come closer. It's this stuff called Silverwood, I think. And I need to plug in my computer too. So I'm going to plug in the computer real quick. And then I want to look up this stuff called Silverwood. Because, so it turns out it's kind of like catnip. It made the cats go crazy. They were rolling around in a good mood, biting it, playing around, being silly heads. It was very similar to when they've been on catnip. So, what is this stuff called? One moment. I just need to look up this stuff real quick. Silverwood. Oh, hi, Dandelion. You're doing cute stretches. Silverwood. No, I'm not talking about a theme park. Cats. Is it not called? Silvervine. That's what it is. Silvervine. Silvervine for cats. It's a species of kiwi? That's so cool. Oh, I already want to make an episode about kiwis. Pets. Silvervine elicits euphoric response in cats. The reaction to Silvervine is similar to the catnip response, but appears to be more intense. Silvervine's an alternative to catnip, and many cats that don't react to catnip will respond positively to Silvervine powder made from dry fruit gals. Typical behaviors include rolling, chin and cheek rubbing, drooling, and licking. The effects usually last between 5 and 30 minutes, but cats are typically unresponsive to the plant for 1 or more hours. So that's interesting and cool. So Silvervine, they were going wild for it. We now have it set aside somewhere. I'll give it back to them in the future sometime. It's just like a stick. I don't even know how long it goes bad or if it does go bad, but they like that stick. It was really cute when they were playing with it. So I'll show you that sometime. And as far as a full video about my cats, I will do that at some point because you know what it's going to be called? I'm sorry, but Dandelion's not going to be the star of that show. I have so much footage of him being... I have a lot of footage of Dandelion. So I'll put a lot of cute footage of him in being a really cute silly head. But the main name for if I do an episode about the cats will be something along the lines of how I adopted a feral cat. Because me and my family here, my parents and brother and me, had this stray cat that was visiting that had no home and was just like a total street wild cat just wandering around, wouldn't go anywhere near you. And now he lives in the house, he got fixed, and over the course of a year, he's just become like this sweetheart and loves pets and stuff. And yep, now there's 3 cats here, because there's also my majestic royal sage, who's Dandelion's brother. So, yep, get me started on the cats, so I'll talk about the cats a while. I love them. They've kept me sane. They're going to get a huge thank you in the finale when I'm thanking people like camera people, my Patreon supporters, who are all going to get your names on a whiteboard. Thanking a few other people who have helped out or have like been super fans. I'm also going to do a big thank you to the cats because they kept me sane and able to be happy over the time. And this Dandelion, let me make it bigger so you can see him better. This Dandelion will go into this upside down pose right in front of you and just like run. Oh, you can't see him. It's too dark. He's like all rolled on his back. It's really cute. Let me see if you can see. Dandelion? Yeah, it's a cute boy. Well, he goes and flops all over with his belly up in front of you and has the silliest techniques. He is the best. Not that he's better than his brothers. Him and Sage are equally magnificent to me. Sage is just a different breed. He's so royal and smart and agile, and he has a lot of certain intelligence and calm. His extra special role is that he's not only so cute, but he's also so silly looking. And when he rolls around in the dirt with his belly up trying to get pets and stuff, it will make me laugh even when I'm in a dark mood. So, that's good, Dandelion. So, let's jump into... We looked at our Silvervine. We're going to jump back into a tiny bit more Titration while, yes, Dandelion, I'll continue to pet you. And let's just imagine, or try and imagine, how would we go about looking... Well, actually, I don't even need the screen right now for this. How would we go about trying to imagine 6 Hexated Six? Well, what would that mean? That would mean that we have a stack of pentation of the number 6 that has 6 in it. Now, what did pentation mean? Pentation, each layer became a Titration amount. And so, bit by bit on that 6 Tetrated 6, the top 6 pentated 6 in that stack will become unbelievably big. And we're just going to be at the top of the ladder. Then we're going to have to take 6 pentated to that unbelievable amount. And then 6 pentated to whatever that is, and 6 pentated to whatever that is. And it's going to be really hard to try and unravel this into smaller boxes of hyperoperations. In fact, 6 Hexated 6, leave a comment how you would approach describing this, because I haven't fully thought it through, but I'm a bit at a lack of how to break down 6 hexated 6 in a way that doesn't involve pentation or hexation, that involves just those lower layers, and use numbers. A lot of the charts that describe tetrations and stuff cut off at a very small number, and they also get to a quick point where they're no longer describing the number, but describing how many digits are in it. And that's an interesting thought, is if you continued that chart, you could say, if there was a way of calculating it, here's how many digits are in how many digits are in the number. You might even have to go multiple layers deeper. How many digits are and how many digits are and how many digits are and how many digits are in the answer. And I actually don't know. Is there a convention for that? If anyone knows, leave a comment if there is any terminology you could use to describe that. Because I feel like that would be a useful concept. You know, having like kind of like a hyperoperation number in brackets, having a way to signify this is how many layers of digit of digit of digit I'm talking about the number. Of course, when you get to that scale, it might be hard to ever know how many it was for something to be able to use, like, how would you know how many digits are in the digits of the digits of the digits when you're talking about these numbers? We have no idea how many digits are in 6 hexated 6, whether we knew how to calculate it or not. We don't even know how many digits are in one of those tiny boxes of so many boxes of layers it has. Now, interestingly, we know one thing. The first digit of that number, tough luck. Good luck trying to get that first digit. The last digit of the number is a 6. Because in our base, 6 to the power of anything is 6. So it's going to be an absurdly large number, too big for the universe to catalog. But it'll end in a 6. So that's fun. Same with 5 pentated 5. Still beyond the amount that we could ever try and compute. But the last digit of that's a 5. Because the last any power of 5 in our base ends in a 5. So, let me jump back to the comments. And thank you all. Someone's saying, whenever I start a stream, it's night there. Well, that's why when I do my weekly scheduled streams, when we have a steady time in March for a few of our weekly streams, there will be one at this time and one much earlier in the morning. I do streams in the morning too, so it might not be ideal for everyone. I can't stream 24/7, but there will be a stream at one of the days of the week. I still need to let you guys know, somewhere around 10 a.m. Pacific time, California, USA time, somewhere around now, which is 7:15 in my time. So, someone's wondering, isn't describing how many digits, the number of digits it has, the number of digits divided by 10? No, it would be so many layers beyond that. If I say how many digits does the number 1 million have, the answer is 7. That's far more than a division by 10. So if I said, how many digits are in the amount of digits of a million, we're down to 1 in the digits of the amount of digits. And so with these ones where the amount of digits in the amount of digits it's such a crazy scale of difference. And someone's mentioning super logarithms, double logarithms, antifactorials and stuff, and those are cool. In fact, related to tetrations, there is something known as a superroot, which is like a tetrational root. Similar to how roots can be seen as similar to exponentiation. Well, like square roots similar to the second power, cube roots similar to the third power. There are super roots that are like a tetrational root. In fact, let's see what they have to say online, if they have anything here about superroots of tetration. Let's see if we can read anything fun about that. I also need to go to this page anyway, because not the superroot part of the page, but the part of this page that is going to have the cool fractal that I do need to show you, even though it was already in the episode a while ago. Fractal's cool enough. People asked about complex numbers. Well, you get a fractal. So, shrinking me and Dandelion again, and we have a lot of chaos as usual. Our delayed stream chat and everything. Now, this is a superroot. You could say it's hard to write the superroot, so ignore how you'd write it. We'll figure out our way of writing it in an episode when we need to, because there's a lot of ways of getting about these hyperoperations. They're not standardized in their terminology enough. But you could say that 2 is the 4th superroot of that number, because 2 in the 4th hyperoperation gives you that. Or maybe because 2 tetrated 4 gives you that. And you can go further. Now, where's these fractals at? Here's an analytic extension of it that looks super cool. This isn't the one I put in the episode. The one that's a little easier to comprehend are these ones, where this is showing the period of the bits that when they go to infinity, or they loop around in little areas, or they stay on the same spot. They made a color coding system for the period of how long a point, when tetrated upward and upward, goes to. And this doesn't have full resolution, but you can see it would be super fractally and just keep going in and in and in. Then there's a similar one, which that's the periods, and this is by how quick they escape to infinity, the ones that do go to infinity. So this is how quick they escape. Tetration by period and tetration by escape, they call it here. And these are some interesting tetrations, like I tetrated 2 is that, I tetrated 3 is that, and so on. Isn't that trippy? I haven't made a video about this yet. I will at some point in the future. But I to the power of I. Real. No i's involved. It's on the real number line. There's a number on the real number line, not needing any i's, that is the value of I to the power of I. Strange. Now, I will warn you guys that this stream might just be an hour, because I have some stuff that I planned after this. So if you do have any special thoughts, leave them pretty soon. And I will check the comments before I close off. And if anyone has any questions, feel free to leave them. Everyone has seemed to understand this name shift part of the operation, where I switched the name in pictures. Didn't seem to lose any subscribers from that as far as I could tell. So that's cool. And tomorrow we'll get our other surprise related to these keys, for folks who didn't see a special one of my streams where those came up. And that's something new that I have planned going forward to make my life more exciting. That's a possibility I'll mention in some stream. And that triangle is a possible better way of doing the logarithm, exponentiation, and roots combo. Those all are secretly connected, if you think about it. They're all different sides of the same triangular coin. The triangular coins are also a story for another day. You know, anytime you make a strange analogy around here, you might be accidentally hinting at a strange episode topic. Now, how long has this been? It's hard for me to tell on my end. It's been, I guess, about 50 minutes or so. And what I will do now is, let's see. I'm going to... Hi, Dandelion. give a quick rundown of the remaining episodes that could be coming up in case anybody wants those. And while I've got this really soft Dandelion, I'll try and get you guys an up close of him in a minute. And what we're going to have next is I'm filming the next one probably tomorrow. And the next 2 episodes are going to relate to one more about different bases, probably. One about spelling numbers, a kind of languagey episode, but still about numbers. And then one about infinite reciprocal series. Which ones converge and which ones diverge. And then we will be on our 36th episode, the finale. And the finale will be long and crazy. And I have a lot of fun plans for the finale, including a field trip. Including I'll probably camp out in the combo classroom for a few nights for fun in a tent. Including telling you guys some really rare stuff about the past year. Including stuff about the 2 surgeries I had to get during the course of making all this stuff. And showing maybe some cameos and or thanks of various people who have helped me on the grade. And the names of the Patreon supporters will get on there real quick. And that will other stuff that I won't tell you yet that's going to be really fun in the finale. Somewhat of a destruction ritual. There will be something involving my hair changing, me tidying up a bit possibly in certain ways, classroom getting tidier with a destruction ritual. And then we'll have our modular reset. But not everything will reset, don't worry. Fans of the chaos will return and slowly accumulate. And someone's wondering about if I will cover Graham's number. Well, Graham's number is pretty cool, but it's not necessarily my favorite of the large numbers. It showed up in a proof once as an upper bound for something. So it did show up in a context, but they, before too long, tightened that upper bound. So it's not like something that's still showing up in papers being used as a proof. It's something that at one point historically was known as a bound for something. So it's, in the context of math, honestly, in my opinion, one of the less relevant ones. I think there's got to be something more fundamental about 6 Hexated 6 than about Graham's number. But Graham's number does use, it can be described with up arrow notation. So we will take a peek at it right now, really briefly. And let me see where we're at with this. I guess I'm big right now. So we're going to, real quick, look at Wikipedia's Graham's number thing. But like I said, although it was the upper bound for a proof, it's a sort of arbitrary way of stacking up these hyperoperations and does not really, like, still show up in, like, equations you'd use. And so, let's see. Graham's number is related to the following problem. Connect each pair of geometric vertices of an n-dimensional hypercube to obtain a complete graph on 2 to the n vertices. So it's this whole question. Now, they noted this bound they found for a while that was pretty crazy. And they have tightened the bounds. So there was this weaker upper bound that I guess was maybe even an unpublished work. So you see what I mean? It's like not historically the most notable. It's just like one of the bounds they had for this equation. As by bounds it means like what you currently know. It must be smaller than that, or it must be bigger than that. So there's something they knew must be smaller than it. And then pretty quickly they tightened that bound to something they knew must be smaller than something else. Now, because not many people know about big numbers, it was interesting to the public when Martin Gardner, one of my favorite authors of all time, like, here is one of my books by him. Any book of his puzzles is highly excellent. I love Martin Gardner. And so he did popularize it, which is cool because people should know about big numbers. If they're not going to know about any big numbers, why not talk about the one that showed up in that era? But let's see what it really is. It's 64 layers of this sort of thing. And we can see it's using threes, it's using hyperoperations, it's using 64. Sort of more arbitrary than something like 6 Hexated Six. Still cool though. Still like it. You know, when people talk about it, they're thinking about what could a big number mean. And it is a big number. So, it is cool. However, there are other insanely big ones, such as, here's another one that we'll cover someday. These busy beaver numbers are really trippy and get really big, incomprehensibly big, and there's a lot of cool big number. Tree 3, we're going to talk about Tree 3 sometime. That one's super cool because it's just the third level of this graph theory problem. And I like big numbers, so I like when people talk about Graham's number, but it's not the best out of them. Sort of arbitrary. Still cool. So, that was a good little tangent. Let's see if we can get a close-up on this beautiful dandelion. He's, as usual, letting me... oh, we actually can, because this webcam's detachable. Alright, folks. I don't know if you can see him. It's too dark. But his belly's completely up, and I'm rubbing his belly. Okay, we'll get some good dandelion footage another time. And yes, my actual light is out, so I'm using a little lamp. Okay, so I'll try and get some really... Okay, here's what we'll do. I have plenty of really good dandelion, hyper cute footage, so... I don't know where my phone is. Okay, if people like Dandelion, go on the Discord. There's already a little Dandelion emoji type thing that you can comment as a reaction to posts. But, oh man, he's so cute. I want to show you so bad. Let me see if I can put this over here and then show you. Oh, that's too dandy? It's okay. So he's getting a little spooked by all of that action, and it's still really hard to see him. But he was being so cute a minute ago. He goes with his belly out, and he flops all the way on his back, so his belly is completely exposed, and puts his little paws in there. So, cat appreciation. I love these guys. So, you know what else I'm going to get soon? Maybe not super soon, but sometime before too long. Something in a fish tank that's over there in the room. But it's not going to be fish. Leave a comment if you were here on an earlier stream and you heard what it's going to be. So, I am going to jump back to the comments and end this stream pretty soon because I got some stuff to do. Like I said, I'll be back tomorrow with some info about those keys and a fun new surprise, as well as filming some great stuff for the main channel. So, you're all super awesome. Thank you for joining me. Make sure to check out the Discord or subreddit if you use either of those apps. And if you do want some bonus content and your name on a whiteboard in the finale, make sure to check out the Patreon. And stay tuned for a lot of fun surprises coming in March, since I will have, for the first time in, for the first time, I will be making this show. I was going to say it for the first time in some amount of time, but with this combo, it'll be the first time ever. For the first time ever, I will have had this show and not a side job at the same time, teaching private music lessons and stuff, and math lessons to private students. So it will also just be the first time I haven't been teaching this type of job of teaching music in like 5 years or something, and I worked retail at a music shop before that. So the first time I haven't been doing something kind of like private teaching / music related as a day job in many years. And I'll be starting in March. I'll make a video about that as the shift occurs, and I have taught my final lesson 2 more weeks with my students, and I will explain more about, the emotions and things behind that process at some point later. But the good news is that means that March will have steady streaming days, March will have extra of every type of content, and I'll have time to work on my books more. So that's all for today's stream. I'm going to cut this off so that I can do some things, and then I'm not going to timestamp it right away, but I'll add some timestamps or chapters at some point tonight. And if anyone wants to be really helpful, you can leave a comment with time numbers of when some of the main topics were talked about when this posts in a minute. If not, I'll do that in a little bit. But yeah, check out those cool links of all the awesome places the Combo Lords talk. And I will see you again very soon. I think I'm getting bad internet now too, so good time to log off. So thank you all for joining me, and I'll catch you again in some shape or form. And actually, I know the shape or form. It'll be a bonus video.